Hey, period five. I kind of goofed and didn't tell you guys that I wouldn't be here this morning, but I have a couple of doctor's appointments. One is my first physical therapy for my knee, which is awesome, and the other one is a pregnancy checkup. So I just wanted to make a quick video to let you guys know what you're going to be doing today and make sure that you feel confident about this pendulum lab assessment that I'd love for you to get as far as you can today. So that tomorrow we just have a little bit to finish up and then maybe we can play some games. That's totally going to be dependent on you all getting your assignment done today, which means that I'm really hoping that you can help support each other to understand the directions. So, without further ado, for our Check and Connect, I have a very interactive Check and Connect with each other, and that is to get out your computers. Right now, if you don't have your computer, you can do this on your phone. And I want you to go to our announcement in Canvas. Remember, that's just the weekly agenda. And when you scroll down to Thursday, you're going to see that the first link here is the pre-conference check-in survey. So we'll take 15 minutes to complete that survey. All right. Awesome. We're back. Thank you for doing that survey. I really appreciate it. It helps me to prepare for conferences. So for our Pendulum Lab, you have access to this slideshow in the same announcement. It's just right below where you got to the survey. You can go to Pendulum Lab number 2, guiding slides, and you'll be able to follow along with this and move through these slides at your pace in order to understand the assignment. Okay, so in our last class, when we were doing the practice, we learned that as the starting angle increases, that is, as we increase the angle that we're releasing the pendulum from, it actually doesn't change the amount of time that it takes for it to complete a swing. The time for a swing stays the same. So I'd like for you all to turn and discuss what other questions could we ask about a pendulum? What else could we change about a pendulum? So pause the video, take some time to quickly discuss, and see if you can come up with 2 things that you'd be able to change in order, and then to conduct another experiment. Excellent. Hopefully, some of the things that we came up with looked something like this. Okay, so how does the mass at the end of the string, and here's our pendulum that we've had in class, okay? How does the mass at the end of the string affect the time that it takes the pendulum to swing back and forth to complete one swing? Or how does the length of the string affect the time that it takes for the pendulum to complete one full swing? These are 2 possible research questions that you can choose. What I want you to do is to take your lab handout, which you're going to be handed now, and I want you to circle which question that you are more interested in finding out the answer to. Do you want to change the mass, or do you want to change the length of the string? Once you've decided on that question, then I want you to identify the variables, and write a hypothesis. I'm looking for a written hypothesis that matches a graph hypothesis. Don't forget to fill out as well why you think that you're going to see what you see. So that's going to be the first page of the lab. This should take maybe 5 minutes or so, maybe a little bit longer, maybe 10 minutes, 5 to 10 minutes to complete this part. Okay. At this point, now I'm just going to kind of go through these next slides to give you instructions about the following parts of the slides. So that's going to be making your data table, graphing your data, and then on the back is completing your conclusion. So there's two ways that you can do this, this activity. You can either collect the data by hand and use physical materials, or you can use a simulation. I'm going to tell you right now that collecting the data by hand will take you longer because you have to make your pendulum. But I think it's a little bit more interesting in terms of getting the chance to really see the effect. I think that sometimes doing it by hand can be helpful to like really actually believe the data you're seeing. Using the simulation is going to be much faster, and you're going to get much more precise data from the simulation. And so I'm going to show you both of these ways. Okay, so collecting data by hand, you can take a look at this. Really, I've got these materials available. As for the electronic scale, just make sure that you're turning it off after you collect your measurements, so we don't use we don't waste batteries. It's pretty easy to understand how to use that. Collecting data using the simulation is going to require you to go to the simulation. Go to intro. And then I want to make sure you have the stopwatch there. So you're able to change either the length or the mass, depending on what you want to do for your experiment. If I pause this, I can move this. I'm going to say, oh, okay, I'll do it from 50 degrees. I can actually turn on this timer right now because since the simulation is paused, it's not going to start recording. And then remember, I want to get the time that it takes for it to complete one full swing, so there and back. So I can do this on normal speed or I can do it on slow speed. I'll go ahead and do it on slow speed for the video. Press play. It's collecting time right now. It's collecting time. It's recording time right now. And as it gets back to the starting point, I'm getting ready to hit pause. Okay. So I can record, oh, okay, so at this particular length or at this particular mass, it took 1.72 seconds to complete a swing. I'll take multiple trials and then I can find the average and then change something. Okay. Graphing the data in Desmos is going to look the exact same as it did for our practice. Make sure that you are going to Pendulum number 2. You can access it through this slideshow, or you can find it in our modules tab. All of these directions should look familiar to you if you did the practice. Remember, you'll use the slider to make one of those lines fit your data. You'll delete the other lines that don't match, and then you'll write in the formula of whichever line best fits your data. So it might be T equals CS or T equals C, and you'll replace C with what your value is that you got. You'll share your graph to the assignment, and then you'll submit it. So all these directions will walk you through that. And I know that you can help each other with this because it takes some technological savviness to do this. All right. You don't have to remake your whole graph on your paper. I just want to see the general, like, was it a diagonal line going up? Was it a horizontal line? And then the equation that you got from Desmos. So don't feel like you need to then replot all of your data one more time. Just giving me a general shape will be great. That's enough to get you started with this. The following slides will help you out with your claim, evidence, and reasoning. So when you get to the conclusion, you'll be able to look at these slides to help you out with that part. So use your time really well today, and make sure that we maybe have about 20 minutes or so left of class tomorrow that we're completing this work. If you have any questions, please ask each other and try to do as much as you can without my support today. Good luck on this assessment.